Okay, we're going to look at numbers 10 and 11 in 3.2. We're just going to calculate the derivative. We're going to be using our newfound derivative rules that we've developed so far. Those include, of course, the power rule. Remember, the derivative with respect to x of x to the n, where n is any constant, is n times x to the n minus 1. So we kind of bring the power down in front as a coefficient and subtract 1 from the power, and that resulting function is the derivative of x to the n. We're also going to use the linearity properties. And so here's the notation for taking a derivative, right? Take the derivative with respect to x, and in parentheses, here's what we're operating on. So what's the derivative of this function? So I'm going to use the linearity rules. There's a sum and there's a difference here. We just take the derivative of each of these functions and then add and subtract as indicated. We also have some constant multiples, right? So we can pull the constant multiples out. So when I take the derivative, I'll pull this -3 out. What's the derivative of x cubed? Well, by the power rule, I'll bring the 3 down in front, subtract 1 from 3, I get 2. There's the derivative, all right? Same thing here, 2 is a constant multiple, pull it out. What's the derivative of x squared? Bring the 2 down, 2x, subtract 1, I get 2x to the first, which I just write that way. And now the derivative of 3x, you can think about it two ways. One is just a line, well, I guess technically a -3, but I'll be subtracting that. So the derivative of 3x is going to be 3 because it's just a line of slope 3, right? Or you can use the power rule if you want, in this sense, right? Bringing down 1, right? And then what? Subtracting 1 from 1 gives me 0. And we think of x to the 0 then as equal to 1. And so this just becomes -3. Cleaning it up then, just multiplying -3 times 3 is -9, 2 times 2 is 4, and there's my derivative. Again, most of you, I think, will go right from this to this answer, not doing this intermediate step, and that's great. We want you to be able to do that as we deal with derivatives of polynomial functions like this. Very simple. Now, this is a derivative using the same rules, although this is not a polynomial function because it has fractional negative exponents, right? But it's going to work the same way. So I'm going to pull the 20 out. This is number 11, by the way. And the power is 5/4. I bring 5/4 down, subtracting 1 from 5/4. And remember, 1 is 4/4. 5/4 minus 4/4 gives me 1/4. Here the 9 comes out again, bring the -3/2 down. If I subtract 1, which would be what, 2/2, from -3/2, -3 minus 2 gives me -5/2. So be careful when you're subtracting signed numbers. And then the derivative of 2x, as we talked about above, is just going to be 2, right? Derivative of 2x would just be 2. A line of slope 2, derivative is 2. And then we clean this up. 20 times 5/4. Now I can simplify that, and you should. 4 goes into 20, right? 5 times, right? 20 is 5 times 4. So I can divide top and bottom by 4, and I'm left with 5 times 5, which is 25, x to the 1/4. Here I'm going to multiply negative times positive gives me negative, and then 9 times 3/2, well, 2 and 9 have no common factors, right? So 9 times 3 is 27 halves, x to the -5/2. So this is what Achieve wants. Now, sometimes I'll ask to write results without negative exponents, and how would you do that? Remember that x to the -5/2 is the same as 1 divided by x to the +5/2. So the negative exponent, -1 essentially means reciprocal, right? I mean, this is the same thing as x to the 5/2 raised to the -1 power. And -1 power means reciprocal. So if I do that and then multiply by -27/2, I get this. So, this is sometimes what I ask for, but this is what they want in Achieve. Okay, hope this is helpful.